Okay, to solve questions 20 and 29. On question 20, we're looking for the length of HF. If you look at what we've been given the length of a leg of this right triangle. So again, we go back to theorem 9.3 that says the length of each leg of the right triangle, okay, in this case 20, is the geometric mean, which is the square root of the product of two numbers, and those two numbers are the length of the hypotenuse, which in this case is 25, and the length of the segment of the hypotenuse that's adjacent to that particular leg. Okay, so if this is the leg, the segment of the hypotenuse adjacent to it would be HF, which we'll just call x. Okay, so we have 25 times x. To get rid of the square root, we square both sides. 400 equals, this squared cancels out the square root, so we have 25x. We divide this by 25, and x is equal to 16. Okay. Now it does say it wants us to write the similarity statement. Again, the similarity statement, I always start with the biggest triangle, so we'll call it triangle EFG. Alright, let's start with this triangle on the left with vertices E, H, and J. The E in this smaller triangle is the same as the E in the larger one, so they have to be in the same place. G is the right angle in the larger, H is the right angle in the smaller, so they have to match up. So then G in this case, this part of G has to match up with this F. Okay, now for the third one, again using the first one as a blueprint, angle F is the same in both. Okay, so we have F in the middle here, so F has to be in the middle here. Right angle is G, right angle is H, G, so H is here again. And then we still need F, H, we still need our G. Okay, so this part of G matches up with that E. So we have our similarity statement and we have our value of x. For 29, all we have to do is find the value of each variable. We have to use our theorems 9.2 and 9.3. Okay, let's start out with the altitude. This is 9.2. It says the length of the altitude, which is 32, is the geometric mean, which means the square root of the product. Geometric mean of the lengths of the two segments of the hypotenuse, which are 24 and x. To get rid of the square root, we square it. So we have 32 squared equals the square root of 24x. 32 squared is equal to 1024 equals 24x. We divide both sides by 24. We get x is equal to 42 2/3. Okay, so that's x. Now we need to find y and z. Y and z are both legs. So if we look at theorem 9.3, it says the lengths of each leg of a right triangle is the geometric mean. Again, so we have square root of the lengths of the hypotenuse, which in this case would be 42 2/3 plus 24. So that would give us 66 2/3 times the segment of the hypotenuse adjacent to it. So in this case, times 24. So that's what y is equal to. Z, the other leg, would be equal to the square root of 66 2/3 times 42 2/3, because that's the segment or length of the segment of the hypotenuse adjacent to it. So let's switch this over to our math setting. Let's see if we can't solve this very quickly. Square root of 66 2/3 times 24. Let's see, let's not get in that far. Let's see. It shouldn't be multiplication there, should it? It should be plus 2/3 times 24. And we get 9.055 approximately. Order of operations is all screwed up there, isn't it? Alright, sorry about that. Make sure we get this right. So let's just say 66 2/3. Let's see, 66 times 3 plus 2 is 200 thirds. So what we'll do is we'll do the square root of 200 thirds times 42 and 2/3. Let's see, that's 128 over 3. Make sure it's reading all of these numbers correctly. Now let's see what we get here. It's not much better, is it? Problem is I don't have my calculator with me. Well, what this ends up being, because I do have the book, what y ends up being is 40. And what z ends up being is 53 1/3. I know that's really sloppy. I apologize for that, but that is the correct answer. And that is how you do all three of these, both of these questions, and how to find all three of these variable values. And that's how you solve questions 20 and 29.